We'll go over the binomial distribution. So when do we use the binomial distribution? That is when the experiment has n identical trials, and each trial has two possible outcomes, success and failure, and where the success is p and the failure is 1 minus p. And all the trials are independent. If all of these four conditions are satisfied, then we can use this equation. So let's apply it to a question. The probability to win a game is 0.4, and you'll play the game 5 times. In here, we do have n identical trials. That is playing the same game 5 times. And each trial has two possible outcomes, success and failure. So winning the game would be the success, and losing the game would be the failure. And you can see that P is a success, 0.4, and 1 minus P is a failure. So 1 minus 0.4 would be 0.6. And the trials are independent, meaning that each game are not related to each other. So, for example, if you were to win the second game, then that does not affect the winnings of the first game, or the winnings of the third game. So that means the games are independent of each other. So if these four conditions are satisfied, then we can use this equation. All right, let's look at this example. Suppose the chance of one tourist visits Ocean Park is given to be as 0.6. What is the probability distribution if you ask two tourists? So visiting Ocean Park, that would be the success. And if you do not visit Ocean Park, that would be the failure. So 1 minus P, that would be 0.4. So method 1, we can have a table in here. There are two tourists, so meaning the first tourist and the second tourist. So the first one, both will go to Ocean Park. And the last one, both do not go to Ocean Park. Or the first one go to Ocean Park, and the second one do not go to Ocean Park. Or the first one do not go to Ocean Park, and the second one goes to Ocean Park. So these are all the combinations. As we defined Y to be going to Ocean Park, then that means we have two people going to Ocean Park for the first row. And for the last row, both are not going to Ocean Park, so Y would be 0. And for the middle two, we can see that either one will go to Ocean Park. So that means Y equals to 1. And we can put the numbers in. So 2 Ocean Parks, that would be 0.6 times 0.6. And both of them do not go to Ocean Park. That'll be 0.4 times 0.4. And then we have two scenarios in here. So the first one goes to Ocean Park, the other one do not go, or does not go. And then for the other scenario, the first one does not go, and then the second one would go to Ocean Park. Then we can put it in a table. Then we get Y as going to Ocean Park, either no one, one person, or two people. Then we get these numbers. All right. So let's use a different approach. We are going to apply this equation. So N in this equation means the total items, and P means the success. So we can see that in here. N is the total items. We have two people. And X would be the number of people going to Ocean Park, and that is 2. P would be the success, so 0.6. And X again is 2 in here. And then we have 1 minus P. So 1 minus 0.6 again. Then N minus X. So N is once again, is the total number of tourists. And X is the people going to Ocean Park. So 2. And if you pop this into the calculator, you should get 0.36. You do the same thing for x equals to 1 and x equals to 0. Then you get these values. I use x in here because the equation says x, but you should put y in here because we defined the y in the us going to Ocean Park in the first method.